Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today I have came up with another interesting problem and another variation of an assignment problem. So let us quickly see what the problem is. So the problem says that a company has one surplus truck in each of the cities A, B, C, D and E, and one deficit truck in each of the cities 1, 2, 3, 4, 5 and 6. The distance between the cities in kilometers is shown in below. Find the assignment of trucks from cities in surplus to cities in deficit so that the total distance covered by the vehicles is minimum. So in this question it has been given that there are 5 cities where one truck is surplus and there are 6 cities where one truck is deficit. So we need to assign the distance traveled by a truck from cities in surplus to cities in deficit. So let us start solving the problem, and we'll solve this problem by Hungarian method. So the first step of Hungarian method says that our assignment matrix should be a square matrix. So here we can see that there are 5 number of cities A, B, C, D and E, and there are 6 number of deficient cities. Okay, so this is 5 cross 6 matrix, which is a non-square matrix. So first what we need to do is we need to convert this non-square matrix into a square matrix. So we need to convert this 5 cross 6 matrix into a 6 cross 6 matrix. So we will do this. This is A, B, C, D and E, and the 6th row we are adding is a dummy row which is making 6 cross 6, and these are cities 1, 2, 3, 4, 5 and 6. These are the cost coefficient. These are the cost coefficient 12, 10, 15, 22, 18, 8, 10, 18, 25, 15, 16, 12, 11, 10, 3, 8, 5, 9, 6, 14, 10, 13, 13, 12, then 8, 12, 11, 7, 13 and 10. And the cost coefficient values in this dummy row is 0. So all the values in the row are 0. So now our matrix has been converted into a square matrix which is of 6 cross 6 size, and to find an optimal solution we need to find exactly 6 assignment in this matrix. So let us start. After making it a square matrix, we need to reduce the matrix so that we have a 0 in each row and in each column. So here we can see that by adding dummy row we have zeros in each column. So we do not need to do column reduction, we only need to do row reduction. That means the minimum value in a row, that is for the row 1 minimum value is 8. So each element in row 1 subtract by the minimum value in row 1. So let us quickly do this. So minimum value in row 1 is 8. So this is 12 minus 8 is 4. 10 minus 8 is 2. 15 minus 8 is 7. 22 minus 8 is 14. 18 minus 8 is 10. 8 minus 8 is 0. Similarly in row 2 the minimum value is 10. So 10 minus 10 is 0. 18 minus 10 is 8. 25 minus 10 is 15. 15 minus 10 is 5. 16 minus 10 is 6. 12 minus 10 is 2. In row 3 the minimum value is 3. So 11 minus 3 is 8. 10 minus 3 is 7, 3 minus 3 is 0, 8 minus 3 is 5, 5 minus 3 is 2, 9 minus 3 is 6. For row 4, the minimum value here is 6, so 6 minus 6 is 0, 14 minus 6 is 8, 10 minus 6 is 4, 13 minus 6 is 7, 13 minus 6 is 7, 6 minus 6, 12 minus 6 is 6. Similarly, in row 5, the minimum value here is 7. So 8 minus 7 is 1, 12 minus 7 is 5, 11 minus 7 is 4, 7 minus 7 is 0, 13 minus 7 is 6, and 10 minus 7 is 3. And here it will remain 0. So now we have zeros in each row and in each column. So next step is that we have to assign in this matrix. So we know that for assigning we will start from row wise and then we'll move column wise. If there is a single zero in a row, then we are going to assign that zero, and if there is more than one zero in a row, then we will not assign and we will skip that particular row and move to the next row. And similarly we will do the same with column also. So let us start with row 1. In row 1 we can see that there is a single zero, that means we can assign this 0. Now after assigning this 0, there cannot be any more assignment in this row and in this column. So as we can see, in this column there is another 0 present. So because this has already been assigned, this 0 has been crossed out. Similarly, moving on to row 2, row 2 is also having a single 0. So we will assign this 0, and after assigning, there should be no assignment in this row and in this column. So because this column has already has an assignment, so now the two zeros are going to be crossed out. Now moving on to row 3, we have a single 0 here. So again we are going to assign this, and after assigning this, there can be no more assignment in this row and in this column. So because there is already an assignment, we will cross out this 0. Now moving on to the 4th row, there is one 0, but this 0 has already become ineligible for assignment. So again we will skip this row and we will move on to the 5th row. In 5th row we have a single 0, so we will assign this, and once this has been assigned, no more assignment can be done in this row and no more assignment can be done in this column. So because this is assigned, this 0 has to be crossed out. Now moving on to 6th row, we have two unassigned zeros. So it has more than one 0, so we will skip this, and now we will start assigning column wise. So column 1 already has an assignment. Moving on to column 2, we have a single 0 here, so we are going to assign this 0, and once this 0 is assigned, no more assignment can be done in this column and in this particular row. So once this is assigned, this 0 has to be crossed out. Now moving on to column 3, this is already an assignment. Moving on to column 4, this already has an assignment. Moving on to column 5, there is no assignable 0 present here, so we will move to column 6, and there is already an assignment. So there is no more 0 remaining for assignment, and as we can see that we have 1 2 3 4 5 number of assignment, and to get an optimal solution we need to have 6 number of assignment. That means our solution is not optimal. And so if our solution is not optimal, next step we need to do is to draw a minimum number of line which will cross all the zeros. Okay, so for that we need to follow certain steps. First step is to tick the unassigned row. So among this is the unassigned row, so tick the unassigned row, and if this row is having a 0, tick the corresponding column. Okay, and if this column has an assignment, tick the corresponding row. Clear? So first is tick the unassigned row. If this row has a 0, tick the corresponding column, and if this column has an assignment, tick the corresponding row. Now no more further ticking is possible. As we can see here, we need to draw lines through unticked rows and ticked column. So unticked rows are these. So we will draw line through unticked rows. These are unticked rows and ticked column. So this is the only ticked column. So as we can see that we have 1, 2, 3, 4, 5 number of lines, because we have 5 number of assignments. So minimum number of lines that cross all the zeros is 5. Now in this particular matrix we can see that there are 3 types of cell. First cell is where no lines are passing. Okay, so these are the cell where no lines are passing. And second is the cell where only single line is passing. And the third is the cell where 2 lines are passing, where we are having intersection of lines. So as we can see here, 2 lines are passing. Okay, so what we will do is we will select the minimum value among the cell where no lines is passing. So among the cell where no lines are passing, the minimum value here is 2. So the value of theta will be 2. Okay, so value of theta will be 2, and what we are going to do is, for a cell which has no lines passing through it, the new cost coefficient, that is new Cij, is equal to the older Cij minus theta. Okay, the new Cij is equal to the older Cij minus theta for the cell where no lines are passing. So let us quickly calculate the new matrix here. Here we have 2 minus theta is 2 minus 2 is 0, so this will be 0. Similarly 6 minus 2 is 4, 5 minus 2 is 3, 15 minus 2 is 13, 8 minus 2 is 6. Now moving on to this, 8 minus 2 is 6, then 4 minus 2 is 2, then 7 minus 2 is 5, again 7 minus 2 is 5, and 6 minus 2 is 4. So okay, all the cells where no lines are passing has been done. Now the cell which are having only single line passing through it will remain as it is. That means the cost coefficient of the cell where only single line is passing will remain same as the previous matrix. So let us quickly write it. This is 2, 7, 14, 10 and 0. Similarly this is 0, this is 7, 705, 705 to 6. Okay, this is 0, then 540, this is 540, 63. Then we have 0, 0, 0, 0 and 0. Okay, and now the third type of cell is where 2 lines are passing. So we can see that these are 4 cells where 2 lines are passing. So in this cell, the value of new cost coefficient, that is new Cij, is equal to the older Cij plus theta. That means if this is 4, 4 plus 2 is 6. So this will be 6. Similarly this is 8, 8 plus 2 is 10. This is 1, so 1 plus 2 is 3. And this is 0, 0 plus 2 is 2. So now we have obtained the new assignment matrix, and now we again need to assign in this particular matrix. We will do the same as we have done in the previous matrix. First we will assign row wise and then we will assign column wise. So starting from row 1, we can see that in row 1 we have a single 0, that means we can assign this. So we have assigned. Once this has been assigned, no more assignment can be done in this row and in this column. So these 2 zeros in this column has to be crossed out. Now moving on to row 2. Row 2 has a single 0 now because this 0 has been crossed out. So we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 also crossed out. Now moving on to row 3. Row 3 also has a single 0, that means we can assign this. So after assigning, no more assignment can be done in this row and in this column. So this 0 will be crossed out. Now moving on to row 4, there is no more assignable 0 is present. So we will skip this and we will move on to row 5. In row 5, there is one single 0 present. So we will assign this 0, and once this is assigned, no more assignment can be done in this row or in this column. So this has to be crossed out. Now moving on to row 5, we have more than one 0. So we will skip this and now we will start assigning column wise. So for column 1, we already have an assignment. So we will move to column 2. In column 2, we have a single 0 here. So we will assign this 0. And once this 0 is assigned, no more assignment can be done in this column and in this row. So this 0 has to be crossed out. Now moving on to column 3, there is already an assignment. Moving on to column 4, there is already an assignment. Moving on to column 5, we have no assignable 0 present here. So we will skip this, and as we can see that no more 0 is available for assignment, and in this matrix we have 1, 2, 3, 4 and 5 assignment, and we know that for an optimal solution we need to have 6 assignment. That means this solution is also not optimal. So again we need to draw minimum number of lines which will cross all these 0. So let us again do the same procedure. First take the unassigned row. So this is the unassigned row. Take the unassigned row, and if this row is having a 0, take the corresponding column. So we have taken the corresponding column, and if this corresponding column is having an assignment, then take the corresponding row. Now after this we can see that this ticked row is having an unassigned 0 here. So we need to tick the column here, corresponding column, and once we can see that if this corresponding column has an assignment, we need to tick the corresponding row. So we can see that no more zeros are here. So no more further ticking is possible in this matrix, and now we need to draw lines through unticked rows and ticked column. So we'll draw a line from unticked rows and ticked column. These are ticked column. So as we can see that the total number of lines are 1, 2, 3, 4 and 5. 5 lines, because we have 5 number of assignment which are crossing all the zeros. So now again we will select the minimum value among the cell where no lines are passing. So we can see that among these cells the minimum value is 2. So the theta value of theta here is equal to 2. Now to make new assignment matrix, what we have to do is, for the cell having no lines passing through it, the cost coefficient of new assignment or of new matrix is the older Cij minus of theta. So we can see that this is 2 and minus value of theta is 2. So 2 minus 2 is 0. So this is 0. Similarly 7 minus 2 is 5. 14 minus 2 is 12. 10 minus 2 is 8. 6 minus 2 is 4. 13 minus 2 is 11. 3 minus 2 is 1. 4 minus 2 is 2. Similarly here 6 minus 2 is 4. 2 minus 2 is 0. 5 minus 2 is 3. 5 minus 2 is 3. Now for the cell where only single line is passing, we do not change the value of Cij. That means the new Cij will be equal to the old Cij. So we will write these values as it is for the cell where only single line is passing. So we can see that this is 6, this is 0, this is 0. Now moving on here, we have 7, 0, 5, 2, 0, 0, 4, this is 6, 0, 4, 5, and then this is 0, 0, 0, 0. So we can see that we have done this. And now the third type of cell where two lines are passing. So these are the cell where two lines are passing. So for these cell, the value of new Cij, that means new cost coefficient, is equal to the older Cij plus theta. So theta here is 2. So we can see that for this cell, this is 10. So 10 plus 2 is 12. So this will be 12. Similarly here is 3. 3 plus 2 is 5. 2 plus 2 is 4. And here it is 6 plus 2 is 8. Here 3 plus 2 is 5 and 0 plus 2 is 2. So now we have find out the new assignment matrix, and now again we need to assign in this matrix. We will follow the same procedure. First we will assign row wise and then we will assign column wise. So starting from row 1, we can see that in row 1 there are 2 zeros present, or we can say there are more than 1 zero. So we will skip this. Now for row 2 there are more than 1 zero, so we will skip this. Row 3 is having a single zero, so we will assign this, and once this is assigned, no assignment can be done in this row and in this column. So these two zeros are crossed out. Now moving on to row 4, we have a single assignable 0 present here because this has been crossed out. So we can assign this 0, and once this is assigned, no more assignment can be done in this row and in this column. So this 0 has to be crossed out. Now moving on to row 5, we have a single 0 here. So we can assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So this 0 will also crossed out. Now moving on to row 6, we have more than 1 0. So we will skip this and we will start moving column wise. Column 1 has been assigned, so we will move to column 2. In column 2 we have more than 1 assignable 0, so we will move to column 3. Column 3 has been assigned, so we will move to column 4. Column 4 is also assigned. We will move to column 5. In column 5 we have a single 0, so we will assign this 0, and once this has been assigned, that means this cannot be assigned because no assignment can be done in this row and in this column. Now moving on to column 5, we can see that there are more than 1 0, so we need to skip this. And after doing this, we can see that there are still three unassigned zeros present here. So we will try to again assign row wise and column wise. So starting from row 1, we can see that in row 1 we have more than 1 0, so we will skip this. And moving on to row 2, in row 2 now we have only single assignable 0 because this has been crossed out, so this can be assigned. So we will assign this, and once this is assigned, no more assignment can be done in this row and in this column, so this will cross out. Moving on to row 3, row 4, row 5, row 6, all are assigned. Now let us move column wise. Once we move column wise, we can see that column 1 is assigned. Moving on to column 2, there is only one assignable 0 is present because this 0 has been crossed out. So we will assign this 0, and after assigning this 0, we can see that we have all 6 number of assignment. That means 1, 2, 3, 4, 5 and 6. So we have all the 6 assignment here, which is equal to the number of which is equal to the rank of matrix. That means 6 cross 6 matrix. So we have 6 number of assignments. So number of assignment is equal to the order of matrix here. That means our solution is optimal, and this shows that this optimal solution is also optimal for this particular matrix, and from this particular matrix we will find the value of z here. So z minimum is equal to, we can see the assignment here, and we will add up the values from the original matrix that has been given in the problem. So this matrix has the value 10 plus this is 12 plus this is 3 plus this is 6 plus this is 13 plus 0. So as we can see, if we add up all this, it will be, this is 15, 16, 31, okay, 12, 10 plus 12, okay, then we have 3, okay, then we have 6, okay, then we have 13. So if we add up all this, this will be 15 plus 10, 25 plus 6, 31, 15 plus 10, 25 plus 6, 31, 31 plus 13. So 31 plus 13 here, 12, 3, 6 and 7. Okay, so the last value is wrong, I guess. Here this value is 7. So now it is 10 plus 12, 22, 25, 25 plus 13 is 38. So this is 38 kilometers. This is the minimum value of z, and the optimal assignment can be given as this, which is equal to A has been assigned to city 2, B has been assigned to city 6, C has been assigned to city 3, D has been assigned to city 1, E has been assigned to city 4. So this is the optimal assignment, which gives the minimum value of z equals to 38 kilometers, and after assigning this we find out that there is no truck that has been sent to city 5. So we can also conclude that no truck is sent to city 5. So I hope this question is clear. So if you like the lecture, please share the lecture. Have a nice day. Thank you.